Going on, Riley? I got a lot to do. Hold on. The thing is, I'm in a vibe right now, and I just can't stand all this bright light. Hold on. Now, this is like closer to the vibe, but it's still, you know, I wish it was just warmer. I wish it was quieter and warmer in here. Alright, so the first thing we're doing is we're using these linear regulators. What are they? Whatever they're called. I don't know what they're called. Voltage regulators. Because I'm about to go get it. I'm about to go get the camera. I don't leave it in here because... Why am I blurry now? What the hell? Dude, I've had such a problem with these webcams, man. Let's try this. I don't know, man. That's pretty... It's probably the glare. Could be. There, that's better. Dude, so... Wait, hold on. We gotta be careful because this always leaks my freaking... Alright, hold on. Okay. So, it's called a linear guide rail. Bro, look at this. 99 bucks. You get two of them. 2.2 meters. Damn. But why would I do that? The point is that I want to build something that at least someone else could potentially be able to buy, make. But the idea is, I think I am probably going to buy this after we get the version 1 done. Because, like, this thing is a toy, man. This thing isn't cool. But if we go to freaking... Bro, if we go to Nerdtronic...
In 2010, this paint...
This guy is freaking awesome, man.
Robot can replicate one of these $1 million paintings. This was a massive project that included design, 3D printing, custom hardware, custom software, digital and physical, and it had many challenges and issues to overcome. I considered different designs, but what I settled on was doing a giant XY plotter. For the frame, I used C-beam V-slot aluminum rails. Paper Source sold these standard plates and wheel kits that can glide along the track. It's a huge structure, 13 feet wide and 9 feet tall. The wall in my studio is the perfect place to build a robot, test it, and to make canvas. All stepper motors are normally used in plotters, laser engravers, and printers. A lot of modern robots like the Boston Dynamics.
What did he call that stuff?
Custom hardware, custom software, artistry both digital and physical, and it had many challenges and issues to overcome. What is it doing? I considered different designs, but what I settled on was doing a giant XY plotter. For the frame, I used C-beam V-slot aluminum rails.
Yeah, that's the stuff. Yo, that's not that expensive, actually. That's pretty good. Can I? I mean, look, I'm not monetized to begin with, bro. I got 300 subscribers. If they're coming after me, we got an issue. But also, I give attributions. It's fair. It's fair. Like, you see my face in the corner and you see his channel. It's not like I'm full screened just reposting the content. But I'll appreciate you looking out. Oh, it's expensive with the black. So you put a lead screw in the middle of this.
Hey, what's up, guys?
Wait, what was this one? Oh, yeah. Wait, is this the... Oh, no. It's this one.
Hey, what's up, guys? It's Dr. D-Flow, and I'm in a new space surrounded by new equipment. I'm going to get to all these changes in a future video, but in today's video, I want to focus on this beast. This is my first ever industrial machine of this size, and it's the Sidekick 8 by Shop Saber. It's a CNC plasma table, and it's huge, and that's the point. I can load up standard 4x8 sheets on this table. Previously, on my smaller CNC
You see that?
table, I had to go to my steel.
Do you see that? That looks like MG rail.
Previously, on my smaller CNC plasma table, I had to go to my steel distributor and get them to shear standard size plates and sheets so that they'd fit on my table. Not only was this more expensive, but it also took longer to get that raw stock material because there was always lead time on the shears. With this table, I don't have to worry about that. I just roll up to the distributor, grab the sheet, and head out, all within minutes. It's awesome. I'm excited to give you guys a quick tour of the table, and at the end of the video, I'm going to talk about some of the things that you have to consider when purchasing a machine like this. Not only its cost, but also all the other factors from...
Yeah, so what I wanted to do is I wanted to look at like a bunch of pen plotter videos. Like look at all of the other pen plotter videos on YouTube and categorize their linear actuation method and all stuff like that.
Transporting it here, to setting it up, to having the right equipment to support it. Let's move over to the side of the table where you guys can really get a sense of how big this machine is. Here you can see the length of the y-axis, the cutting capacity of the
Okay,
machine.
see how this one uses a rack and pinion and linear rails. It seems like it's pretty common to use a rack and pinion on a plasma cutter, and I feel like the reason why you use a rack and pinion because, like, why don't we use a rack and pinion? Why don't I use a rack and pinion? Then the motor is moving too, which is kind of a... Racket? What do you mean it's too small? This table is huge,
is
bro.
98 inches by 52 inches. So a little bit bigger than that 4x8, which gives you some wiggle room to make sure that you can fit the plate and cut all of it. What makes all this cutting possible is the steel frame, which is more thermally stable and stronger than aluminum. So when you're cutting long hours and you're producing a lot of heat, this table is not going to distort like an aluminum extrusion table might. Now the cutting capacity of this machine is 2 inches. Now I don't care how big that block is, that is going to be super heavy. So what you can see here is that this table has 6 legs, 3 on this side, 3 on the other side, and that's going to prevent it from sagging. If I pop this cover off, we can take a look at the transmission setup, or what converts the rotational movement of the motor to the linear motion of the table. Now unlike lower cost systems that may use a
I'm guessing it's closed loop.
lead screw that wobbles or a belt that stretches, this table uses a rack and pinion setup where you'll have a circular gear, which is on the other side of this block, which rides along this linear track. Now the benefit of this setup is that this is extremely robust and resistant to dirty environments. Dust and grit from the plasma table can get into the rack and it's still going to move. Also, as you extend the rack longer and longer and longer, it still operates basically the same. You don't see those artifacts such as lead screw wobble and belt stretching with this type of transmission. Now the main drawback for this besides cost is going to be resolution. These teeth are huge, so each rotation of the circular gear is going to cause the gantry to move a far distance. To combat this limitation, Shop Saber went with a planetary gearbox, which is going to further increase the resolution of the rotating shaft of the motor. for this transmission, I've kind of worked backwards because I want to save the best for last. This table uses a servo motor to drive the rack and pinion. Now, I've talked about servo motors in my CNC mill upgrade video, but briefly, they are superior to servo motors in about every way possible. Only are they quieter, they're closed loops, they know when they missteps, but they also have very high instantaneous torque, which will allow the table to accelerate the torch in and out of corners really quickly so that we don't see kind of those artifacts occur when you slow down and the plasma is searching for more material to eat up. So servo motors are amazing on this table. Now, what keeps all this motion in a straight line is this 25mm linear rail in conjunction with these huge bearing blocks that's going to keep everything straight and everything really rigid. Let's pop our...
That's amazing that you can actually put so much weight on a... The motor would have to be two... You're saying for a rack and pinion?
Around back to the front of the table, and we'll talk about the X and Z axes. The X axis, which as you can see on this picture, is this guy right here, and it's virtually the same as the Y axis. It has a rack and pinion driven by a servo motor with a planetary gearbox, twin 25mm linear rails, 4 bearing blocks, 2 on each rail. Rigidity is the name of the game for this table. With plasma, there's not really any force that has to be overcome when cutting.
Wait, what would grind against the plywood? Now you could put it above it. You could put it above the linear rail. Could you? Hold on. Could you? No, what you would do is you'd put it to the side and then you'd flip the motor either this way or something like that. It's really nice that they get that big steel table.
Beyond expectations. You know, a more well-built table is going to survive delivery. It's going to survive in a shop environment. It's okay if you bump into it, it's not going to lose its squareness. Now, the Z-axis is a little bit of a different story. Instead of a rack and pinion, we have a ball screw. Now, typically, with cheaper plasma cutters, you'll see a lead screw here, but the problem with lead screws is that they're very slow. And during the cutting process, you're lifting up and moving to new locations to start new cuts quite often. And this takes a lot of time. So the faster you can get the torch retracted to the next location and down, the faster your cuts are going to be. And this ball screw is going to allow for really quick motion, especially since it's driven by a servo motor. And again, we see these twin 25mm linear rails. In case you're wondering, we have about 9 inches or 230mm of motion right here. This allows the torch to be retracted way up, which makes it easy to load material and just keeps the torch out of the way when you're not cutting, which is awesome. Now we can zoom in on the torch and its mount. If you saw my DIY CNC plasma cutter video, you'll know that I used a floating head for the mount so that the torch could be physically run into the material in order to determine the height of the material. Now that parameter is super important because if you don't know the height of the material, you don't know where to position the torch to get that perfect cut. Now the problem with that floating head, with that physical contact with the material, is that if you use really thin material, the torch will dent it, which will give you a false starting height. Now obviously this table employs a much more sophisticated way of sensing the height of the material, and it's known as ohmic sensing. Now instead of physically running into the material, this wire in a dedicated circuit will sense the resistance between the torch tip and the material. The closer the tip gets to the material, the lower the resistance. This is great for thin material. So there's no floating head here, but the torch is still kind of on springs. And what's happening up here, there's 2 proximity switches, and if the torch leaves the vertical position, well, that's a collision. Those switches trigger, it tells the controller to shut off all motion. Very slick. I love plasma cutting as a CNC tool. Perhaps the only downside is the fumes and dust that are generated during the cutting process. Now, Shop Saver offers 2 different options for dealing with these fumes. The first is a downdraft table, which will physically suck those fumes out of the cutting area, down to the table, and out of your shop. That is a great technology because it's not very messy, but it does require significant sized blowers to make sure you have enough airflow to really suck all that dust out. Now, as someone that's always filming, you know, I'm looking for the lowest amount of noise possible. I also like the easier solutions because with that draft table, if one of the blowers were to break, you'd be kind of out of luck until you get a replacement. So I went with the second option, the water table. Now, I talked about this again in my previous plasma cutting video, but basically the water acts as a trap to all of the exhaust and fumes. Now, the downside of the water table is that all that grit and grime has to be cleaned out at some point, and there's a bunch of mild steel slats surrounded by water, so your tendency is going to be to rust. But I used some of this plasma defense with a 3 gallon of this concentrate to 100 gallons of the water, and I'm hoping that this is going to inhibit some of that rust from forming, because this is a huge table. The bigger the table, the more opportunity for rust. The water has actually been in this table for a couple days, and the slats are actually looking really nice. Obviously, there's some grime here because I was taking some.
This is so good. Is this Italian guy? I think this guy's sick.
Folks, today we are going finally to make ourselves a plasma cutting machine, just recycling a very, very cheap and vintage welding machine. So let's get started, but first, intro.
That's awesome. I love that.
Until today, I always use my angle grinder to cut pieces of metal for my projects. But this restricts me to cut only straight lines. But with the plasma torch, instead I can follow weird shapes, I can cut circles, I can cut everything I want. So this is so important for my shop. And the goal of today is to build it without spending money, just recycling things or buying very cheap parts. You cannot take the plasma torch and connect it directly to the welding machine. In this configuration, it will not work. The name itself explains the reason why. We need to form and create plasma inside the plasma torch and put this.
Okay. Should we just get started here? This video is so good. The idea that you could maybe create vias at home is nuts. So yeah, so that's cool. This one was super impressive, bro.
I could hire someone to do it for me. Hello, my name is Steven, and I've got a problem. In my day job, I'm actually a cinematographer, so I'm kind of obsessed with moving a camera around in cool ways. The problem is, I'm getting lazy, and while I could hire someone to do it for me, well, then I'd be the director. And people require things like pay, and food, and dignity. So I decided it's time to automate the filming process and build a robot that can do it for me. And so I did. This is Marge. I call her that because she's large. That's it, that's the reason. And while it's really cool that Marge works at all, she's not exactly up to the task of getting cool shots like this. And this isn't really surprising since Marge is mostly made of plastic with some carbon fiber and aluminum tubes bolted on for fun. Now, I'm not entirely positive, but rigorous scientific testing does seem to indicate that aluminum is just a little bit stronger than plastic. But until recently, I just didn't have a good way to deal with it. So I made a few friends who could help me out. Enter the gang. Lathe, mill, CNC, joined by bands, and featuring drill press. With these puppies backing me, anything's possible. The world is my oyster. My shop is the envy of all who... Oh, crap. The world is my oyster. My shop is the envy of all who...
Yeah, I don't really need brains.
Oh, crap. So how do we even start on a project like this? Robots are complex, consisting of many custom parts, tons of wiring, electronics, sensors, and a whole host of other systems. They are usually designed by big teams of engineers and other specialists at large companies. And I'm not an engineer, and I don't have a lot of resources at my disposal. But what I do have is the power of denial, and an incredible ability to block out those nagging feelings of doubt that start to creep in as the enormity of this project begins to dawn on me. So let's start small and worry about the rest of it later. So we'll begin at the wrist. But what exactly do I mean by that? We can break down a robot arm by the number of axes, basically the number of rotational points. In our case, we're building a 6-axis arm, which not so coincidentally is pretty much exactly how a human arm is built. And this all ends at the wrist. And though it might be the smallest assembly in the robot, there's actually a lot going on here. For one thing, because of physics, weight at the end of the arm is bad, but the wrist still needs to be rigid, because a floppy camera is no good. It's also complex because the assembly contains 2 out of 6 of the total joints in the robot. So there's a lot going on in a small space. But that means when we finish the wrist, we're a third of the way through the project. Basically. This side plate has a critical bearing fit, so it's a good...
You gotta go? I don't know, bro. My schedule is weird. Probably tomorrow. You know, I try to go every day. I skipped out on a few days here, but I try to do it every day. But I don't know the time. See you, Riley.
First test piece to try, so I got right to it. The machine doesn't work. Popping through that aluminum like it was butter, and before I even knew it, I had the first finished part, like magic. And then I measured it. Wow, circles are not even close to round. And yeah, the other dimensions aren't right either. So what am I doing wrong? I had watched all the YouTube videos, I had cut some test parts and dialed in some speeds and feeds, and I'd made all the appropriate sacrifices. Or so I thought. Now I had
Yo, what's up, bro? Yo, I messaged you a bunch. Oh, yeah. Wait, what'd you say? Yeah, overwriting the pixels. And then the UI, yeah. Alright, so right now, I guess I didn't need to hop into this. Basically, I need to test this thing, so I need to go get the camera at some point. But this has been driving me crazy. Alright, so we got a little breadboard here. I just need to get one of these voltage regulators. And we need to get the pinouts for this shit. Oh, shit. This is so annoying. Wait, did these go in or no? They do, but barely. It's real thick. I think all... Alright, so let me get a voltmeter really quickly. Alright, let's see what's going on. I don't know, what was the first message? No, I just had a bunch of thoughts about it. Yeah, I just rewatched that Nerdtronic video on stream again. That video is so good. And yeah, I think I do want to make it huge at some point. I think that would be freaking awesome. Alright, so let's just get started. We got so much stuff to do. Not worth thinking anymore, just doing. Alright. So the main thing is I need to look up the thing is, I feel like it was all sus. Like, it was always weird. What a terrible picture. Okay. Alright, so, I'm pretty sure that this thing at the end is what's grounded. Alright, so this should be grounded. And wait, let's do a continuity test. Okay, so that's not that. It's not that either. Sometimes they do it to the output. I need a little heat sink kit. Yep, so it's the output. They always do something janky like that. Alright, we're going to see if this works. We're going to give this thing 12 volts. Okay, so here, let's figure this out. That's okay. Alright, so here's what we're going to do. Okay, so I drew this circuit down. Basically, we're going to need to take this apart, and we're going to need some jumpers. Let me go get the camera. So I'll set up the camera, and then we're just going to do this thing. So it's going to be a regulator. I need another Arduino. Okay, we're going to need some breadboard jumpers. Alright. Let's just figure this out. So, it's always so hard to see these things. Alright, so let's do red. Let's get a red cable. Fuck, this one's soldered. It doesn't really... I guess it fits. Alright, so that's V plus... Do all of these agree? All of these... See, not all of these agree, bro. That's what I'm saying, though. It's like... That's kind of what's insane about this, actually. Is like... You buy them from different places and their pinouts are different. It's kind of insane that the pinout is actually different. So, does this thing have a pinout on it? That's so fucking annoying, bro. Also, that's not even what they gave me. They gave me something totally different. They gave me the V5. Alright, let's just write down what it says. Does anyone say the pinout? It's all just shipping. How do you... What does it say on it? It says L7805 CVGOOKJ V5 CHN 248. Looking at the front, pins downward. The left pin is the input, the ground is the middle pin. Okay. Yeah, we have this one. TO220. I love that. Okay, so let's just assume it's right. It probably is. Whatever. Oh yeah, okay, hold on. Let's just wait, I have a big ass to-do list. Yeah, I'm gonna do that Cloudflare thing tonight, I promise. I gotta do it off stream because it requires too much authentication shit. But I will, I promise. God, I was slacked the hell off yesterday. Alright. I felt so overwhelmed by this thing. Like I literally set it all up and then I just like didn't do it. It's okay. Alright, let's figure this thing out. Okay, so the first thing we gotta do is we just need to hook up a digital pin from here. Okay, so this is gonna go like this, but first we want a voltage regulator so that we don't fry this thing. Alright, so this thing will be live. I just gotta get those little wires. Oh, God. Okay. Lots to do, lots to do. Wait. That's fine. I know. I was reading about tunnel yet today. I was chilling in my room. Just reading about tunnel. Alright. So ground. Oh, I guess what we want to do. Yeah, is I want to do this. Ooh, it's super easy to yike this thing. Okay, so voltage. Alright, let's do it. Why is it reading 0.9? Is this thing getting hot? No. That doesn't make any sense. Hold on, let's measure. Let's measure this pin. 12. 0.8. What the hell? What? Oh, fuck. Alright, let's just try another one. Maybe that one's defective. What? What was it exactly? Oh, wait. Did I just flip it around? Alright, if we burn one, I don't give a fuck, honestly. Alright, there we go. Okay, so that's... Jesus. Okay, so I'm gonna write this... Where's the Sharpie? Where's the Sharpie? I got a bunch of freaking Sharpies. Honestly, that's kind of like a sensical thing. Alright, so we figured it out. We got the pin out. Okay, so the other one probably worked too. People trying to trick me. Alright, so now the next step is getting this thing to this. Alright, so we're gonna need... So let's unplug the thing. So we don't fry anything while we're hooking it all up. Okay, blue for ground. Why not? Okay. This for 5 volts. Okay. And then this for signal. So this is just gonna be like digital pin 8 or 9 or something. Okay. Okay, so now we just need to open up Arduino Studio. Oh wait, let's just open up Sweep. That's always the best. Servo Sweep. Attach 9. Yeah. Okay. So let's just run it. It should just work, right? We're gonna plug this in. Okay, I heard it do something. Ooh. Let's unplug that. Let's make it go from 30 to 150, 150, 30. Let's upload that. What the hell? Okay, what if we kill it? Try it again. What the hell, man? All right, let's do 50 and 100. Not sweeping. I don't understand this thing. There, it's like at its bottom. Why does it do that? What the hell? Do we need a subreddit? It's a good idea though. But do we need it? Why isn't the servo doing what I want? The second you hook up power... What the fuck? Let's get another servo. Okay, but it seems like the regulator works, but... Alright, it seems like the regulator works. Well, I guess we're good. That's basically the heaviest that's going to be. I mean, the pen doesn't weigh really anything. Okay, so that means we got to bust out the soldering iron. Okay. Alright, so we did the thing. So... Okay, so let's get this out. Also, do we need some sort of history? Yeah, we'll need to log history because the coolest thing was the time lapses. And we want to be able to recreate the time lapse digitally. But we should log that in the request. Like when we do tracing, we should already have that. Okay, so this should be enough. Oh. Yeah, but then do you need to do auth? Do you need to do authentication and all that? Seems hard. Okay, so I think I can fit it on one of these boards. Let's see. 14. Okay, so let's But how do we get you? Where does the user ID come from? It's just an integer based on their IP or something, or I don't know. How does that work? Oh, that would be cool. Highlight all the... Yeah, that would be cool. Okay, so let's unplug this thing. And we're going to figure this out. So this is going to go onto here like this. Wait, but then how do you get... These proto boards actually kind of suck. Random UUID. But based on what? Because, like, how do you know that this one user is the same as another user? Oh, I guess you just lay down some wire here. I guess that's what you do. This is going to be kind of a pain. Alright, so we have this. And then what we're going to want is... I guess we're going to take this. How do we want to do this? You create a header on the first visit? What does that mean? Okay, well, how does this circuit work? Oh, okay, but so if like someone leaves the website and then comes back, is it the same or is it different? Okay, well that's perfect. Nice. Okay, I guess we want to move this over here like this. In case we want to mount it. These proto boards kind of suck. Alright, we're just going to grind through it. We're just going to figure it out. So, is there a way to... I thought it was like fritzing, but I hate fritzing. Okay, and then this isn't going to fit, is it? In these tiny little holes. Oh, it does. Nice. I feel like this is going to be a total nightmare. But I also don't want it on a breadboard. Okay, what am I gonna do? Yeah, I kind of hate these proto boards actually. Because how do you connect any two things up together? Alright, whatever. I guess we're just going to start by doing it. So, I'm just going to go do it. This is going to be a total freaking mess. Alright, I'm going to go get the camera too. Okay, so... Okay, let's just try it. If I fail, I fail. Okay, so... Shoot, do you have whiteboard markers? Where did the whiteboard markers go? I gotta keep track of things. Oh, here we go. Alright, so... What's the circuit? Alright. It's gonna be... And then this needs to go to a 3 terminal block. And then we're just going to do another terminal block. So this is going to be where we can have it. Okay, I believe that's it. So we need the terminal blocks, and we're just going to do it all with terminal blocks. So we need 2 more 3s. Okay. Okay. Okay, then we got our strippers. This is the thick wire. Should be okay. Okay. So this should basically be it. It's just an input. This thing goes to the yeah, okay. Okay. So let's figure this out. I didn't really do this exactly right, but that's okay. Let's at least do this if I'm not gonna do my fucking camera. Oh, of course, and it fucking bugs. Ugh, damn it. Okay, give me a sec. Okay, I'm back. Alright. I also got a surge strip and a fan. Okay. Where's the cable? Where is my cable? Cable. Oh, here it is. It's this fat boy. It's this fat boy, son. Okay, we should have a reasonable scene now. Oh, you know what it is? Alright. Test. Okay. All right. Okay. Let's see. Can we do this at all? Oh shit! Wait, this isn't right. This needs to go. This. See if we can speed this up a little bit with. So this is important. Let's see. This is red. Oh shit. Fuck. Okay. I guess. Fuck. Honestly, I don't even know how that helps. Dude, these are so bad because they don't provide the connections themselves. These things kind of suck. Damn. It seems fine. That's good. Okay. Last connection, I think? Question mark? Fuck. That's good. That's good. Okay, it's maybe the worst. It's maybe the worst circuit I've ever made. But we can try it out. Wait, hold on. Wait, this is red? Okay, so what we want to do is test the blue. Okay. So we want to test the blue. We want to test the black. Alright, so this is sort of a moment of truth. Plug this bad boy in. Fuck. Oh, wait, no, we're good. 5 volts. Okay. Let's make sure that. So this. 5 volts, okay. 0 volts. 12 volts. 0. Unconnected. Alright, cool. So I guess we did it correctly. Very cool. Alright, so let's unplug it. Okay. Now let's wire up the rest, baby. Oh, this is going to be so sweet. I'm going to be so happy to get rid of all this crap. Okay, so the first one that's easy is that we're gonna unconnect this. Be gone. Be gone, wall warts. That's right. And they said I could never kill you. They said I could never kill the wall wart. But I replaced 2 wall warts with 1. What does that make me? Alright. So this thing just needs to go. This isn't that permanent, unfortunately, but I guess it's fine. So this is Z plus. And it's going to go not to this one, but to this one. Such a goofy circuit, bro, but whatever. Okay, so this thing goes into here. And tighten it down. Okay. Now we just need to power it, so we're gonna get a couple of short cables. Do we want them to be removable? Oh, wait. This is a dummy. This can go back to whence it came. Alright. So I think this wants to be pretty short. Okay, so red is pin 1. Let's just get that down. Okay. And all right. So now the only last thing is, and this is a little unfortunate. I think I might want to use, actually, but that's not going to work. Shoot. Ugh. Whatever. That's okay. Doesn't have to be perfect. But I feel like this is always going to fall out. I could cut off the end and make this a terminal block. And then it would be terminal block to terminal block. Or you know what? I could just take the end off of this and plug this into there. Why don't I do that? I spent so much time crimping this cable, though. I feel like I don't want to break it. Let's leave it like this for now. Maybe it works. Okay, we need a black cable. Okay, so first in there. Okay. Almost done. We still gotta go into the config and change the homing direction of Y. Alright. One wall wart to rule them all. Alright. So limit switches. Bring out your livings. Limit switches. Alright. Bring out your dead. Alright, so this is Y. We're going to put this on the Y minus thing. Even though it says Y, yeah, I guess it says Y minus. I don't really know why there's different ones there. And then X plus. Alright. So we got the limit switches now. And then we get the ground. And it's all on a common ground. Alright, so I think we're pretty much ready to open up GRBL plotter. Okay, let's close this and reopen it. This webcam is just fucked up. I don't know. Okay. I guess that's all it needs when I click that button. Alright, so let's see. Does it have... It's probably because Arduino is open. My god. Arduino IDE just sucks. That's really what it comes down to. Wait, did I just change that? I think it's 23, right? I'm pretty sure I need to set this to 3, right? Okay, so let's try to home it. Oh, wait, let's open it. Fuck. What's wrong? What's the state one again? Oh, it has it up here. Alright, so it knows about this. Well, that's good. Okay, why is it instantly getting reset? Why is it instantly getting reset? That is a very good question. I believe it could potentially be that the stepper motors are not plugged in. Although I can't say that for sure. Wait, what about now? Please? Damn it. Fuck. Oh. Alright, wait. I got it. It's gonna work. But that's fine. That's the standard error. What? Why? What the hell is going on? What if I just close this program? And what if we go to... I mean, it's the same thing. It opens up the connection. It just sends it all through here. So let's just do... Why does it... You know what? I'm gonna try changing... Okay, let's see if we kill the alarm and do. Well, that works. That's nice. And what is going on with the limit switches that's causing this issue? I don't get it. It detects when it... Both belts seem fine. just don't understand it. Why does it fucking error? Oh, bro, I'm so silly. I could just read once in a while. I would never read. Come on. The fuck? Hey. Wait, where's the pull off? I think that happened a long time ago. That's really weird. Alright, well, we figured it out. Let's see if we can make it 6 and see if that'll work. That's pretty good. Alright, let's do some testing, bruh. Let's do some freaking testing. This thing works, man. Fine shit, boy. Fine shit, boy. Alright, so where do I put my pens? Okay, so first I think let's start off with a standard okay. Let's get started. The hell? That one's good. There we go. Wait, this isn't right. Hold on. We gotta go pen down. And actually what we want to do is I want to give it a custom one. Just slightly up. And then let's get our pliers. Yeah, that's tight enough. Alright, that should be fine. What we want to do is let's home it again. Oh, shit. Oh, see, that's what I'm saying. Oh, but it's not down yet. Okay, let's go pen 0. Home. And then we want to go... What does that end up hitting? Oh, it's just this. We could cut that off. Okay, we gotta home it again. We gotta cut that off though. Where did I put that tool, bro? Where did I put that tool? It's not gonna work. We need the right tool. Oh wait, it's right in front of me. What the hell am I doing? Okay, I bought 10 more meters of belt, so I don't really care anymore. Alright, now. Alright, so let's set the maximum. Oh my god, I hate cables. I hate wires so much. They're all so stupid. I've never met a wire that I liked. Okay, so what was it? Oh. 220. Hell yeah. That's what I'm talking about, family. This is technically, but actually what we want to do is we want to go to pen up and come back over on Y. So this is 242. That's pretty good. Okay, so that's actually kind of it. 200. So we went from, did we go to 250? Damn. But we have room for the tool changer there. So it's not the worst. But this is now 200. So now we're limited by that. Okay, but that's okay. I think everything, oh wait. I think everything should work. So, recent file, DB. Okay, G-code transformation. First off, this is fine. And then, the dimension in Y is bigger, which is good. So, set by Y. Oh wait, don't we want to set by X? No wait, let's set by Y. And then make this, what was it, 220? So we'll make it 210. And Y, X is at 202. So let's actually change it. G-code transform, set by X. Oh wait. Alright, that should be good. Fuck it. Let's home it one more time. See how it does. First test on the new setup, man. Terrible. It's so fucking loud. And the image quality has gotten so bad. It's terrible. I'm gonna try this. I'm gonna try to do just another pass, and we're gonna set this to like 122. I'm gonna drop this bad boy. Wait, what am I doing? Why am I being so stupid? Yes. I'm gonna try one more time. At 122. Okay. Yeah, we do have. Yeah, you're right. Thank you, bro. I appreciate that. All right, we're gonna try it one more time. Same dick butt. So I'm thinking there's a problem here with the wobble this way. I still definitely need to redesign the Z-axis no matter what, which is super unfortunate because I was hoping to not have to change this mechanism again. But we're gonna try to run it one more time. Yes. God. Okay, so what we need to do is find a Because it was always on the other side. I get it. Okay, so hold on. Kill the alarm. Pen 0. Home it. Okay. So what I think I need to do is we need to find that the Y offset has to be like... Wait, so what? First off. Wait. G-code transform. Set Y by 210. But we can't set Y by 210. We gotta set it by like 200. And then at least 10. Let's set it to 190. Just whatever. Okay, so it's small. And then the Y offset needs to be like 15. And I think we should be good. I gotta figure out something about these cables. I just don't know why it's so fucking noisy, bro. It's so goddamn loud. Okay. Okay, so what we're gonna do is we're gonna send. So wait, I want to send an S130, and then I want to send an S140. Okay, there's no difference. What about a 29? Nothing. Or 29? Yeah, but there's so much play in this thing that it doesn't even matter effectively. Okay. 129, 128. 27. 6. 5. I think 5 might be good. What if we do 6? Six at the bottom of its thing. I don't know where this play comes from. I guess it's all in that hole. That hole needs to be better. Okay, so at the bottom, alright, so where's the good Sharpie? Is this it? Yeah. Okay, so we're going to put it in at 126. And we're going to tighten it down. Okay, then we pen it up. Okay. Grab a piece of paper. Okay. Oh shit, I didn't want to do that. Fuck. There's no undo setting. Okay, wait, hold on. Let's just, fuck. What the fuck happened there? Oh no. What the hell is going on here? Ugh, gosh. Well, it quote unquote works again. So I don't know what to do. I guess it is finally time. We gotta redo this Z-axis one more time with a spring. I bought springs. I got some new springs. So technically I... It's like this thing wobbles back and forth, which introduces play into this, I think. Maybe. This being at the end of such a long lever is not great either. I thought it would help with deflection, but maybe we just gotta get lower. I mean, there's no real problem. We could get way lower. Right? Can we get lower? If we put the... I don't know, man. All right, that's it for tonight. It's 11:30. We did part of it. I'm gonna do everything else tomorrow. We're gonna redesign the Z. It's gonna be great. It's gonna use a spring finally again. Ugh. And we gotta deal with the wires, bro. The wires are driving me absolutely crazy. It's like all over the place. 'Cause when they're out here... That's what I was saying. It's like, what if we put this, like, over here? And I don't know, somehow prevented... I guess I need a wire thing. Like a thing specifically for wires. Oh gosh. Never underestimate my ability to make a total piece of fucking junk. Alright,